Let's take a look at some of the introductory information we're going to be covering. In science, we're going to use the International System of Units, sometimes called the SI unit. That's sometimes mistakenly called the metric system. It's not a big difference. One of the things we're going to use in this, instead of having a traditional textbook, is this wiki book. Now, here's the wiki book, and there are lots of different readings that I will have posted in the activity list for you to look at. That's important for you to go through and do on your own. We are not going to spend time going through the reading together. Because this is a college class or a college prep class, you're going to be expected to do that on your own, trying to prepare you for what it's like in college. You're not going to do those readings together. They're going to be outside your own time. So the prefixes in the metric system, there are a whole bunch of them, but we're really only interested in these 7. Okay? Billions, millions, thousands, hundreds, thousands, millions, and sometimes billions. So you're going to want to make sure that you know what these different prefixes are and the power that goes with them. I've included a YouTube video on the scientific method and some reading. You can go through that on your own. But let's talk about scientific notation. In scientific notation, we express things in powers of 10. We have 1 digit to the left of the decimal point. We only include significant digits. And I'm going to get to significant digits, and you need to make sure you do some reading on that. That's what students have usually the most difficulty in the first whole month of chemistry. How to do significant digits. Talk to each other, talk to me, do some independent researching on the internet, look up YouTube videos, do the readings I've provided. But here's some examples. If we have a value that's larger than 1, our exponent's going to be positive. And if we have a value that's less than 1, our exponent's going to be negative. This bar underneath shows which values are significant, and that's why they're included. These leading zeros are not significant. So let's take a look at some of those rules. Significant digits are important because they represent what you've actually measured. And so all non-zero digits are significant. Ending zeros without a decimal point are not significant. Leading zeros are also not significant. Zeros are only significant when they're at the end and you have a decimal point, or they're what's called captive or trapped. They're in between things. Let's take a look at some of those examples here. So if I look at this first value, I can see that I've got 1, 2, 3, 4, 5 digits there. Well, this is a non-zero, so it's significant. This is also significant. This zero is trapped in between. It's significant, non-zero. And this ending zero is significant because there's a decimal point. All 5 of those digits need to be included in the scientific notation. If we move the decimal point over 1, 2 spots, we can see we have 3 point, and we would write everything else, and we moved it 2 spots, so it's times 10 to the 2. In the next example, significant, significant, underlined makes it significant. These are not significant. They're still part of the value, but they're not going to be included in our scientific notation. So if we imagine our decimal point there, 1, 2, 3, 4 places. 1.2. We indicated that this value was significant, so 1.20 times 10, we moved 4 places. Here, leading zeros are not significant. The decimal place goes 1, 2, 3, 4 places backwards. So we're going to have 6.9 times 10 to the minus 4. Here we have a combination of things. Leading zeros are not significant. Trapped zeros are. And ending zeros with the decimal are significant. So all 4 of those digits need to be included in our scientific notation. 4.080. Don't forget that last 0. And how many places did we move the decimal point? 1, 2 backwards, so it's times 10 to the minus 2. When we are talking about doing calculations, we need to make sure that our answer only contains as few significant digits as we start with. All of these are significant, so that's 4. This 0 is significant because it's after a decimal at the end. 2, that means we've got our answer should have 2 significant digits. Let me quick grab a calculator. When I multiply those, 2.674 times 2.0, I get 5.348. But I need to round this to 2 significant digits. So here's my cutoff point. Does a 4 keep the 3 down, or does it round it up? Well, 4s round down. Then we need to take a look at our units. We've got meters. Oh man, I got to divide that, not multiply it. Oh. 2.674 divided by 2 equals 1.337. Again, 2 significant digits. The 3 keeps it the same, 1.3. That's a bad 3. And when I have meters divided by meters, something on top and the bottom is going to cancel out. That's my actual answer. On the next one, 1.65 times 10 to the minus 7 divided by 2.4 times 10 to the minus 9. My calculator shows 68.75. I have 3 significant digits there. I have 2 significant digits there. Here's where I'm going to round. A 7 rounds it up. So you're going to get 69. Again, kilograms divided by kilograms. There's our answer. On this next one, 4 significant digits. 4, so our answer should have 4. 2.688 times 5.086. That's what my calculator gives me. 1, 2, 3, 4 significant digits. This 1 keeps it the same, 13.67. Now let's take a look at our units. Meters per second times seconds. These units are going to cancel out, and we're left with just plain meters. We're going to continue the process for the next one. There are no units there. 2 significant digits. This has 1, 2, 3 significant digits. So our answer should get rounded to 2 significant digits. My calculator gives me a 0.05772 more. I only want 2 significant digits. Remember, this one does not count because it's leading 0. So 1, 2. There's my cutoff point. I'm going to use the 7 to round up. 0, 6, 0, 5, 8. On this last one, 3 significant digits, 4 significant digits, centimeters times centimeters. So I know my unit's going to be centimeters squared. 2.58 times 9.206 equals 23.75148. 3 significant digits in my answer, so I count 1, 2, 3. There's my rounding point. 5s round up, 23.8. My answers included 3 significant digits. I've got my units. Everything's good. I'll leave you to try and do these conversions using those metric prefixes on your own.